Hello guys, I'm Supreme Khimre and I'm here to teach you why gravity is not a force but actually is just deflection of path. Well, from the beginning of your science journey, you have been taught that gravity is a force, gravitational force, gravity is just nothing but a force. But why does teachers taught that? Because the force that is defined and taught to you is given by Sir Isaac Newton, who was obviously greatest scientist of many say all time, but arguably he is. And I would like to say you something. Well, the thing I am going to say you about gravity is within the overall universe, but the thing Newton has given us by the definition of gravity works perfectly, exactly perfectly within the earth, not in outer space. Okay, outer space Newton's gravity fails, where we will study about the modern gravity stick, but at the earth it works perfectly. So teacher teaches you, the school teaches you and defines you the gravity according to Sir Isaac Newton, not according to the modern science or Einstein's science. Okay, well, the definition has begun. Now let's start about it. Well, let's start from the beginning history. Before the Newton's discovery of gravity, there was a concept called Aristotle's gravity. Aristotle's gravity, well, obviously Aristotle was the father of science, beginning of the scientific universe. And when that was the period of time, the Aristotle had given us some of the theories. Like, he had said that if this pen, suppose this is a pen, why does this pen go always downwards? Aristotle had given the explanation that every body in the universe tends to be more stable in the lower state. So as lower as it goes, it just tends to be more stable. So it goes to downwards. But that was just works on Earth, not outer space. Because if we see the Earth and Sun, there's no point that too. How does the Earth just revolve around the Sun? Like it is not going downwards. There is no direction in the universe, in outer space. So that doesn't make any sense. So at 70th century, Sir Isaac Newton had given us the one of the most perfect definition of gravity yet mistake as we talk about it. And as Sir Isaac Newton had given the equation of gravity as F is equal to G m1 m2 by d square. Well, it works on Earth perfectly, like perfectly, but it doesn't actually work on outer space because it just tends to have some flaws. Like the first flaw I would like to tell you that, and also give the example why Newton's gravity just fails, is that think about light. Okay, the black hole, there is black hole. Newton didn't know about it. There wasn't technology, so it's not his fault that he had misconcluded it. But still, we need to study. Yeah, we can't just stick with Newton's gravity. And to talk about why Newton's gravity fails and at what cases it fails, let's just talk about it. As you know, the light, obviously it's the, what is the light made up of? It is made up of photons, tiny particles. What is photon? Photon is just a packet of energy. And when we talk about it, photon doesn't consist of any mass. You may be wondering why this photon doesn't consist of mass, because if it consists of mass, if you hit, you are just hitting the light itself right now. And if something is hitting you, then it should exert force. But if it is hitting you and it doesn't exert force, means it doesn't have either acceleration or velocity, or either it doesn't have any mass. As we know, the light has the velocity 3 into 10 to the power 8 meter per second, and obviously it consists of acceleration. So as we know, then there must not be mass. If there was mass, anything that is so dense and hitting us with the speed of light, we would just completely will be dead if someone just on the tossed at us. So it just doesn't make any sense. Yeah. So that means light doesn't consist of any mass. Okay. If light doesn't consist of any mass, the problem is that how does a black hole bend the speed of light? Like, you have listened so many times that even light cannot escape from black hole. But how? If Newton's gravity just consists of G is equal to m1 a F is equal to a G m1 m2 by d square, 1 m1 is 0 because light doesn't consist of any mass. So when we take light in the black hole, light mass is actually 0 and black hole mass obviously it's near to near infinity. So as we know, light has 0 mass, so it means no force should be accelerating on it, no force should be applicable on it, but still light just bends towards the gravity. Okay, means Newton fails here, right? Exactly. And then there comes the Einstein's general theory of relativity, where there are two theories of Einstein. One is general theory of relativity, now there is special theory of relativity. We're going to talk about the general theory of relativity. Okay. Well, Einstein had told that just the general theory concept is that the space, outer space, is just nothing but a fabric of time and space. When if a body consists of mass, it just bends the space, means it just bends the direction of body. Like what Einstein told, that if this is a body in space or anywhere in the universe, if this is a body, then it just bends the space-time fabric with its mass in fourth dimension. Okay, we can't see it, the bending of space-time, because it's in fourth dimension and we are just living in third dimension, and we can obviously see only in two dimensions. So we can't see the fourth dimension. It's just that we can't do that. So Einstein's this general theory have told that if the gravity is nothing but just the bend of space-time curvature. Okay, if this is space-time and space, and if this is an object and it just bends the space-time fabric, so it bends. Okay, if another body is approaching within the space, then it comes and it's just goes and collide with it. Why does it collide? Because it has bended the space-time fabric, and the original direction of it has been changed towards it because of the deflection of space-time fabric and concentration of it due to its mass. And every body does that. Even I am attracting you. Obviously you are from the future, so I'm not accurately attracting you at this moment, but I'm attracting you at that moment. Okay, so let's just go into that. Okay, imagine here is a ball which is very dense and it just bended it, and here comes another object towards it, so it will just go and collide with it. Why would it collide? Because its original direction has been changed due to the space-time curvature of this body. So gravity is just not only that. I have explained you only the basics of it, and there's a lot more that Einstein had given to us. So that concluded that light, which is actually nothing but photon, you may see light in here, doesn't consist of any mass but consists of momentum, which helps it to just bend it. Like if space-time bend, then light coming here, it also bends towards the space-time. That is the conclusion why light also cannot escape the space-time curvature. So yeah, it is like that. And not only because of black hole. Okay, black hole has just ripped the space-time fabric due to its dense property. So light is coming so fast that normal gravity can't even touch it. Like if this is the bend, then light goes like this, like inertia. Okay, but if it is ripped apart, then light just falls upon it. So light has been bended. Light is so fast, it's the maximum limit of the universe within the speed. So it just goes from normal, like this object can't bend light that way. Like it bends in some cases, like if light is coming here, it may go to deflection, but it doesn't go and collide with it unless the space-time fabric has been torn apart. So yeah, that's it. Thank you for watching. You may like, you may subscribe. That's your thing. You may do whatever you like. So bye bye guys. See you in the next video.